Hi everyone, welcome to coding tutorial 10 of neural networks and deep learning. My name is Everly. In today's class, we're going to learn how to predict text with RNN, and we're going to build an LSTM model with preprocessing a corpus into character generation dataset and then train the model. And then eventually we're going to predict a series of characters with this trait model with given data. So let's first load these modules. So the first step is data preprocessing. This is the corpus we're going to use today with articles and chapters. And you can take a look at this link and see what's in there. So we're just going to use Keras to get this text file from this link. So let's run this cell. And all right, now it's loaded to this path. So before we start to train a model, let's first take a look at the setting of text generation, and then this will lead us to how to create the data set, how to preprocess our data before training the model from this given corpus. So the problem is written here. Given n characters, we need to have the model predict the next character after the given series. So for example, if this is the given corpus, the sentence deep learning is fun, period, the first step would be converting all the characters to lowercase. So we don't want the characters to be distinguished by whether it's uppercase or lowercase. So the first step is to convert everything from the whole corpus into lower cases. And then the second step is to determine the size of n. So in this example, let's assume n is 5. And with the number 5, we can create the training data from a sliding window with size of 5. So in this sentence, the first sample we can generate is the first 5 letters, the 5 characters. Um, that would be for the training, which is X. And with the given 5 characters, we're going to have the model to learn the ground truth, which is the 6 characters, which is this one, L. And then with the sliding window, we can always determine the step size. So let's just assume the step size is 1 here. So we can have from the second to the 6th character to be sample 2x for training, and then the y, the prediction letter, will be the 7th, and so on. So with this data set, with this corpus, we'll be able to create a series of samples for the model to learn from, and that would be the training data. And the next step, so now that we have all the characters determined, the next step we'll have to encode these characters into the features that our model can be fed on. So in this case, in this whole sentence, we have in total 14 different characters, as shown here. So to encode these characters into features, the next step would be to convert all these characters into one hot encoding. And in this example, for every character, the length of this feature would be 14, and then we use one-hot encoding to differentiate the different characters. So we can see here we have a dictionary to convert the character into the vector. So after that, we'll just create the data set based on the dictionary and convert all the X and Y samples into vectors. So for example, if we have n equals 5, then the training data X would have the size 5 by 14, and then Y would be 1 by 14, which is a vector with length of 14. All right, so with that, let's start coding. The first step, let's read the corpus and then convert everything to lower cases. So the text would be from what we just loaded, the path, and then read. So we'll have to decode it and then determine the encoding as UTF-8. So this should help us load the corpus. We'll just call the corpus text and then convert everything to lower cases. All right, so now we have the data ready. Let's first count what's the total number of characters. And then we further count the number of different characters, unique characters in this data set. We can call that vocabulary or dictionary in this case. So the number would be the length of vocabulary. Let's print that out. Unique characters. All right, let's run this cell. Okay, so the total length of this whole corpus is this, and the unique characters, the number of unique characters is 57. So this is the data we're going to work on, and with that, let's proceed to the next step, creating the data. So let's first determine the size n, and then use one-hot encoding to convert this data set in this corpus into our data set with the features. So encoder, for this vocabulary, every character, enumerate. So every character, let's create um, zero array with length 57. So let's do an array. And that would be 57. And then for this array, this index, which is what we enumerate here for each vocabulary, we assign it as 1. So we will get this dictionary over here. For each character, it has its own feature. So for an encoder, determine the character to be this array. And now we have the encoder ready. So we can further, so here we can further determine a map from the index, as we have here, to map to the character, because we're going to have to use this dictionary later. So determine this for the index to go to the character and just enumerate our encoder. And we don't need the values. Just enumerate the encoder and then items in here. Alright, so let's run this cell. And now we have both dictionaries ready. And for the next step, let's start preparing the data set and create all the samples. And before that, we need a number n, which is the length of the sequence. And in this case, let's try using 40. You can always change that value and try out different training methods, try out different data set setting to see what works better for your model. So the Windows step, let's use 10 here. You can try 1 so that your model can basically train on a larger set of data. But let's do 10 for this example. And for data X and Y, for simplicity, we're just creating the training data using this corpus. But if you want to test the data set on a test set that the model has not seen before, you can first divide the corpus into training and testing, and then create the samples. And now let's use a loop for a range from 0 to the total number, the length of the corpus. And we need to do minus n here. And a Windows step. All right. So with that, we can have x from our corpus with this I, and then to I plus n. So all right, so this is the text. It's what's shown in step 3 example here. Let's first create this and then do the encoding. So for y, we have the I plus ands, and that would be for prediction. Now let's convert everything to the features. And we can get the encoding from what we created in this encoder dictionary. So let's do encoder I for I and X. So for each character in X, where there are in total 40 characters, we convert everything to one hot encoding and then create a new array based on that. And Y encoded would be np, oh, it's already an array, so let's just do encoder Y. And with that, we can have our data to append the new data, and data Y would append Y encoded. All right, let's prepare the data set. Oh, yeah, that was a typo. So for Y, it's only one character for prediction. Cool. So now we have the data set ready. Let's just make sure the data, oh, sorry. So now the data sets are in array. So let's convert that into NP array. So X for training and Y and find the shape. So this is the total number of samples we have in this data set, and the length of this is the second dimension would be the length of each training data, which is the number of characters we have for X. And then the final dimension here is what we did for one hot encoding. And for this corpus, we have 57 unique characters. And for Y, the prediction, we're only predicting one character. So the first dimension would be the same as X, and then uh, again one hot encoding. So the length would be 57. So with all that, our data set is ready. Now let's try building an LSTM model. So for this model, it's going to take a little more time to train. And just to be safe, let's save the checkpoints while training to make sure that we don't lose the model. So let's first load the model from Keras and the layers we need. From Keras models, import sequential, and from Keras layers we need dense, we need dropout, and we need LSTM. Oh, and then we need to save the checkpoints. So from Kara's callbacks, model checkpoint. All right, so let's first have a model ready and add layers. So for this model, it might train for a while, so let's just do a smaller model, and you can always try a bigger one. But I'm just going to do one LSTM layer for this one. So this is the size, and then input shape would be X shape, because we don't need for input shape, we don't need to determine batch size. So this is the shape of our input. And then for here, we'll just add a dropout layer, say 0.2, and add a dense layer for prediction, before prediction. And for output, it would be the shape of Y, and for activation function, softmax. Alright, and with this model, we can do compile, and for this, we can use categorical cross entropy again, which we should be pretty familiar by now. And optimizer, atom. Alright, so we have the model ready. Let's run this cell and then proceed to saving the model. Determine the file path first. That would be content drive, my drive, and for my Google Drive, I'll do name it LSTM tutorial model. So the checkpoint, let's create model checkpoint with this file path, and then monitor on loss, and then the mode. Alright, so I have the checkpoint ready, and now we can train the model. So model fit or X or Y. Number of epochs, let's do 20 epochs for this one. Whoops. And batch size 128, and we'll need our checkpoint. Alright, let's run this cell. Okay, so now the model started training. Um, it's going to take a while. I'll wait for the 20 epochs to finish, and I'm stopping the recording now. We'll resume after the model finishes training. So now the model's done training. We can see the loss dropped through the 20 epochs. It looks like it can still go a little bit lower. So you can always try a larger number of epochs. And after that, we can load the model weights if needed. So in this case, since my session is still running, I'm not going to run this cell. Um, so for the final part, let's do some predictions. We can first determine input sequence with the same length, which is 40, starting from random start. Start data is determined as a random integer here. This is the total length, and we'll just randomly sample a start character. So the input would be from the corpus to 40 characters. After that, plus 40. And then let's print input. And we can have a text string here for generated. Let's run 100 characters for this prediction. So let's do a for loop and determine every time the input would be the last 40. And then don't forget to encode from the dictionary. And then for prediction, we have model predict, and the batch size would be 1. And with that prediction, we can grab the index using argmax. And the result would be that character from this map dictionary that we created with the index. So the generated string would be added by the result. And here we update the input so that every time in this loop we grab a new input x. So after that we print predicted. All right, let's run this cell. Uh, so this is the input we get, and then the predicted 100 characters is here. Um, so this is the result from the model that I trained with the above structure and hyperparameters, trained with 20 epochs. And here's the result. You can always change the hyperparameters. You can add more layers to the LSTM model to see if it performs better. So that is all for today's tutorial. In this tutorial, we learned how to process text data, and then we trained an LSTM model. If you have any questions regarding this tutorial, feel free to stop by my office hours or leave your questions on Piazza. Thank you for watching. See you next time.